So in this module, I'll deal with the theoretical part of migrating over a virtual machine. We'll get into the discussion of the different types of migration. We'll go in a bit, some bit of detail into that with vMotion technologies, storage vMotion technologies. I'll save the demonstration for the next module, where we'll get into our vSphere web client and set up and perform a vMotion and storage vMotion operation, both to migrate our virtual machine from one host to another and to migrate from one data store to another. Okay, so let's get started with this. So we have a few different types of migration here. We have coal migration, we have a vMotion migration, and then we have storage vMotion. These are the different types of migration. Okay. So migration really is moving our compute, our memory, and our storage resources from one host to another or from one data store to another. All right. A coal migration. This is a migration type where we'll move a virtual machine from one host to another whilst it is powered off. So we could manually power off a virtual machine on a host and manually copy that file over to a different host. That would be an example of a coal migration. With a vMotion migration, this is where we are moving a virtual machine from a host that is powered on to another host that is powered on. So a virtual machine is running and we move it from one host to another. Okay. We'll get into vMotion in more detail in a little bit. Next, we have storage vMotion. Here we are migrating a virtual machine file while that virtual machine is powered on from one data store to another. Okay, so I have some detail on vMotion here. So vMotion is the process of moving a running virtual machine from one host to another. So we're basically moving the processing and the memory hosting resources between hosts. And there are a number of reasons why we may want to do this. Why we may want to move our virtual machine from one host to another. Mainly, we would do this to balance the load on our host. Also, we may want to do this or we may want to migrate a virtual machine from one host to another in situations where we are doing planned maintenance or upgrade to ESXi host, for example. So rather than power off that host if we are taking it in for maintenance, we'll just do a vMotion migration of that virtual machine or those virtual machines that are powered on the host. And once we would have migrated all of our VM off of that host, then we could safely bring that host down. So vMotion operation, it works by migrating the entire state of the virtual machine. So the state information would include the memory contents pertaining to that virtual machine. This would include the OS and application data, as well as the hardware elements pertaining to that virtual machine, like your BIOS info, CPU, your devices, and MAC addresses. vMotion is also utilized by the Distributed Resource Scheduler or DRS service in vSphere. This is used to migrate VM across a host to balance the resource utilization and basically to improve overall hardware use among our hosts. We'll get into the discussion of DRS and storage DRS towards the latter part of this course. But for a vMotion operation to be successful, there are some special requirements that must be met before we could get this to work. And I'll discuss this in an upcoming slide, the different requirements for vMotion. I'll discuss both the VM and the host requirements. So we'll get to that in a little bit. Next here, I have the different migration steps for a vMotion operation. In step one, the virtual machine memory state is copied over the VM network. So it's copied over the VM network. The VM network is basically a VM kernel port that is configured on our ESXi host, and it's enabled for vMotion traffic. But once we get to our demonstration module, I'll get into the details of that. So in step one, the virtual machine memory state is copied over the vMotion network from the source host to the target host. So user requests, they would continue to be received on the source host with a list of modified pages of memory being stored in a bitmap file on this host. That's the source host. Okay. So in step two, the virtual machine memory is copied from the source to the target host, and the virtual machine is sequenced on the source. Also in this stage, the VM device state and memory bitmap is transferred to the destination host. In step three, the virtual machine starts to run on the destination host. And then after that, a reverse ARP request is used to notify the subnet that the VM MAC address is on a new switch port. Okay. Step four, the user requests are sent to the VM on the new host instead of the initial source host. And in the final step, the memory pages that were used on the source host, those would be marked as being free and would be released back to the VM kernel in that source host. So that could then be allocated to a different virtual machine or some other process on that ESXi host. So I've divided the requirements for vMotion into two parts. Here we have the vMotion VM requirements, and next we have the vMotion host requirements. So as I mentioned, for a vMotion migration operation to be successful, we'll need to ensure that a number of prerequisites are met for that VM. So firstly, the VM that we are migrating, that VM should not be connected to an internally only switch. As we mentioned in our introduction course, an internal only switch is a vSwitch with no uplinks connected to it. Secondly, the virtual machine that we are migrating should not have a connection to a virtual device such as a DVD or a locally mounted ISO image. Thirdly, we will want to ensure that we don't have any CPU affinity configure. And finally, if we have any raw device mapping configure on that VM, it should also be accessible to the destination host. Okay. Those are the more important requirements for our VM. Next, I have the vMotion host requirements. So as I mentioned previously, for the vMotion operation to be successful, we'll need to ensure a number of prerequisites are met. In this case here, we would want to ensure that the prerequisites are met between the source and the destination host. Okay. So firstly, we would want to ensure that the source and the destination host both have visibility to the same shared storage. So for example, they should have visibility to the same fiber channel or fiber channel over Ethernet, iSCSI, or NFS data store. Secondly, we would want to ensure that we have at least a 1 gig network in our host. Ideally, you would want to have 10 gig networking between your hosts if you're pushing a lot of vMotion traffic. So thirdly, we would want to ensure too that our VM kernel ports that support vMotion traffic, it is identically named on the source and destination host. Okay, so when I say identically named here, this includes case or case sensitive names. So other than the identical names on our VM kernel port that would be supporting vMotion traffic, we would also want to ensure that we have identically named VM port groups. This is to prevent having VMs that are disconnected from the network after they are migrated. Okay, so if your VM on the source host is connected to a VM network called VM network 1, for example, you'd want to ensure that that identical network is also on your destination host, VM network 1. Okay. Finally, the final requirement here for a host, we'd want to ensure that the CPUs on the host within our cluster, we want to ensure that they are from the same vendor. So we won't try to do a vMotion operation from AMD host, for example, to an Intel host. Okay. We'll also want to ensure that the feature set of the source and destination host CPUs they are compatible. If they are not compatible, we'd want to ensure that we use the enhanced vMotion compatibility or EVC feature. We'd want to enable this on our cluster to hide the CPU features. Okay. Once we start the vMotion migration process, if there are any compatibility issues, we would have the opportunity to rectify those errors before we continue, or those compatibility issues. We'll have the opportunity to rectify that before we move on. We'll see this in our demonstration once we get to migrating one of our virtual machine. Finally, we could also use the Windows-based vSphere client to verify the vMotion requirements. We could do this by going to the Maps tab for that virtual machine. From the map, we can determine the relationship between the VM network, the host, and data source. This map is not available with the vSphere web client. It's only available with the vSphere client. But once we get to our demonstration module, we'll cover this too. We'll have a look at the map. So next here we have storage vMotion or storage vMotion migration. So storage vMotion is the process of migrating the virtual machine files from one data store to another data store. And there are a couple of reasons why we may want to do this. We may need to move our virtual machine files in order to balance the load or to migrate to a new storage system. Say we are now implementing a shared storage system. We recently deployed a SAN, and we were running our VM on locally attached disk previously. We could use this storage vMotion feature to migrate our virtual machines from our directly attached or locally attached storage to our shared storage. Okay. So in summary, storage vMotion, using storage vMotion, we are migrating the storage resources for a VM from one storage system to another. We are doing this whilst at the same time we are leaving the compute and memory resources intact. Okay. So with vMotion, we would move the compute and memory resources. With storage vMotion, we are moving the storage resources for that VM. So storage vMotion uses an I/O mirroring system to copy the disk blocks between a source and destination data stores. If these blocks are changed during migration after they were initially copied, then they are then synchronized from the source to destination. This operation is completed using the VM kernel data mover on the ESXi host, or it's offloaded to the storage array if that array supports the vSphere storage APIs or integration. Sorry, for array integration or VAAI. Okay, so VAAI is basically hardware acceleration capabilities on our storage array. Okay. Storage vMotion is also utilized by the storage DRS service. This is used to intelligently place a VM file in the appropriate data store in a data store cluster at VM startup. Okay, and it could also balance the storage resources utilization based on capacity and latency on those data stores within the data store cluster. But we'll get to DRS implementation in a later module. Okay, so we have a couple considerations here we should take note of with storage vMotion. Firstly, we would want to ensure that the host where the VM is running, it has access to both the source and destination data stores. A storage vMotion operation would present us the opportunity to change also our virtual disk type from thick to thin provisioning, as well as to rename our virtual disk. So we could capitalize once we're doing the migration to do either of these tasks. Um, Cross-host storage vMotion. This is where we need to migrate the compute and memory resources from one host to another, whilst at the same time we also want to migrate from one storage location to another. As of vSphere 5.1, vMotion operation does not require an environment with shared storage. Okay, so the requirement for this is that the host should be part of the same layer 2 domain and be part of the same vCenter server.